So this video has secants, tangents, and angle measures. So all sorts of types of lines shooting around your circle. The relationships are all similar though, so it's not too bad. Secants, tangents, and angle measures. We have to identify, we know what a tangent is. We talked about tangents yesterday. It's a circle that has a 90-degree angle. A secant is a line that goes through a circle. And it's going to cross a circle at 2 points. So if I was to have a circle right here, a secant might look like that.
Carlos
There we go.
Salas, please come to the main office. Carlos Salas, please come to the main office.
Now, we're going to have 3 properties that utilize this line and your tangents. So, nice thing is you got your notes for your quiz. So make sure you take notes on these. So we have the secant, interior, angle theorem. And we're going to work with 3 properties today, or 3 setups. And if secants cross inside a circle, you have a circle with your secants, and let's just label these guys A, B, C, D. Angle 1 is going to be equal to this arc plus this arc divided by 2. So the angle measures, we're talking the angle measures here. So angle AB plus the arc measure or angle measure of CD divided by 2. So angle 1 equals the measure of AB plus the measure of CD, all divided by 2. And that could remind you of vertical angles. It reminds me of vertical angles because these 2 guys are across from each other, so you just add the 2 angles together, but then you divide by 2 to find individual. Same thing is true with angle 2. If I wanted to find the measure of angle 2, I would add the top arc with the bottom arc, and I would divide by 2. So there you have it again, the vertical angles there. Add them up, divide by 2, and you've got your inside your circle angle measure. The second relationship we're going to see is with the tangent. I'm not running out of space here. And secant intersection. So with the tangent and a secant, you have this situation right here. And you've got this right here. We'll call that the tangent. And we'll have a secant like that. So we'll just label. So we have E, B, D, A, we'll put C over here. C. So if we wanted to find the measure of angle ABD, this little guy right here, so I'm going to ignore this guy here, measure of angle ABD, I take this arc and divide it by 2. So all you do is find the arc, divide by 2. So that's pretty similar to an inscribed angle, because we did the same type of deal there. Now, and if I wanted to find the measure of the other side, measure of angle ABE, I would take the major arc and divide by 2. There we go. And again, these guys very similar to your inscribed angles. The last relationship you're going to see is two secants that cross. And I think we can fit it here. Any intersection outside a circle. See, you'll notice these guys, this intersection crossed on the circle with a tangent and a secant. This intersection crossed in the middle of the circle, anywhere in the middle. Now we're talking about outside a circle. And the formula, I'll draw the picture first. So the situation is you have something like that. And you'll notice, it kind of looks like one of those optometry things you might see, like a picture of an eyeball with the light coming in, hitting the back of the eye. Anyway, you have a big arc right here, you'll notice. And you have a small arc back here. Okay? And if I wanted to find angle E, what I would do is I would take my big arc and subtract my small arc. Oops. I'm just running arc. Wow. So big arc minus small arc. There we go. We're not dividing by anything. Equals your angle. And then we divide all that by 2. I think I divided early there. So if you want to write it again, angle E equals big minus small, divide by 2. I should have probably just done that. But there you go. So we will run through some of these next in the examples video.